So for this question 5, given our fx and gx, find the inverse function of fx and gx and verify this equation. So we review this question because we want to do this inverse using the new method, which is composite method, follow our latest syllabus here. Firstly, find the inverse of x. So the inverse of f can be obtained by the concept of composite, where if you want to find f inverse means we're going to start with f inverse x equals to x. So we're going to substitute our f inverse into the function of fx. So this x will be replaced by our f inverse. Therefore, they will give us a result of 2 f inverse square plus 1 equals to x. Then we slowly simplify this and let the f inverse stay at left hand side. So move the 1 to the right hand side, minus 1. Then divide by 2. Then we're going to square root it. So when you move your square, we have two answers, positive and negative. Then look at the domain we have. When x more than or equals 0 means it always positive. So that our f inverse will come to the answer of positive square root x minus 1 over 2. Then we go for G inverse. So when you want to find G inverse with composite method means G inverse will get x. Substitute G inverse to the function of G. So this x will be replaced by G inverse. Then find your G inverse. It will be x plus 3. After that, we're going to verify this equation. So this is composite function inverse. Firstly, we get this composite function g of x first, which is 2x squared minus 2. Then from here, we're going to proceed where finding is inverse. So not using the lab method instead of using the composite method. So by the composite method, if you want this inverse, GF inverse, we will start with GF, composite with GF inverse for the x, you get x. So it seems like F inverse, F inverse equals to x. So GF inverse, you will get x. So we will substitute GF inverse into the composite function GF. So this x will be represented by GF inverse. Therefore, our answer here will be 2. And then GF inverse square minus 2 equals to x. Slowly we simplify this. So GF inverse for the x, move our 2 plus 2, then divide by this coefficient 2. So we have a square. Simplify our square. It will be positive negative square root x plus 2 over 2. Then continue. Since we can see our functions here, f inverse here, we start with function of f. Our function of x is only taking positive. So when it composite, it will follow the original of the function. So the function here original is taking positive value of x. Then it composite also, it will limit this answer by taking the positive value only. So therefore, since the domain here given is more than 0, so our GF inverse will be taking the positive answer only, which is x plus 2 over 2. Therefore, this is our left hand side. So for the right hand side, no problem. We'll take back F inverse, composite G inverse. So we take this G inverse, substitute in. Then we substitute into your F inverse where this X will be replaced by X plus 3. So this one no problem. We just want to refine our method in finding inverse, which is F inverse, G inverse, composite inverse by using composite method.